Hello, my name is Jamie Ma. My student ID is 219824366. So we're going to be solving for velocity and acceleration at point B. So first, given that length of the rod to be 5 foot and radius from here to a center to be 3 foot, we can set the radius as a height of this, and we can solve for the x component of r from A to B, which using a Pythagorean theorem, we found out to be 4 foot. So r from A to B is equal to negative 4i minus 3j. Both are negative because to go from A to B, you have to go down and you have to go left. So using the value that we got from this question, we can solve for velocity of B. Now, we're going to multiply the angular velocity times k, and we're going to perform a cross product, which we found out to be this. And we're going to be solving for x and y component. Now, x component of the velocity is going to be 0 because at this point there is only a vertical motion. So 6 plus 3w, both are x component, is equal to 0. And isolating for angular velocity, we found out to be negative 2 radian per second. Plugging this in to a y component, which does have a velocity because the vertical motion exists at this point, we're going to be plugging in a value of angular velocity into here, and we found out the angular velocity to be 8 foot per second. Now, second, we're going to solve for acceleration of B using this formula, which we got, and then we were given a acceleration of A to be 3 foot to the left. So we're going to perform a cross product here using the same logic, and then we're also going to perform a cross product here using the same logic, and acceleration of B is as follows. Now, there is one thing to note, that at point B, the normal component of the acceleration is going to point towards the center, and at the center is exactly at a horizontal distance from point B. So we can solve for normal component of acceleration, which using this formula is, we found out to be 64/3. So we're going to be set the horizontal component of acceleration B into 64/3, the normal acceleration, and isolating for angular acceleration, we found out to be 25/9 radian per second square. We're going to plug this back into a original acceleration formula, and acceleration is 21.35 foot per second square. Now, obviously, there are some challenges with the design. The first one being that rod is a form of rigid body, which cannot be bent or change the form. That is a problem because at different point, the distance between A and B is going to change, and the required distance is also going to change for the rod, and the rod cannot be bent or curved in any form. Also, if you look at the formula, velocity of B, we know that at certain points, especially the curved path, the angular velocity is going to be very inconsistent. It's gonna be very rapid change. And as the angular velocity changes rapidly, the velocity of B is going to change rapidly, which is going to make the entire system very, very unstable. Thank you for listening. That's it from me.